In this video, we look at the issue of subtyping and introduce a principle involved in this topic called the Liskov substitution principle. As we have seen, inheritance is quite powerful, and it is very tempting to subclass quite often, but there are some disadvantages with inheritance. One is that deep hierarchies can be very hard to understand and use sometimes. The number of attributes and methods increase with each level, and the methods can sometimes be difficult to understand because of their complicated relationships. In Java, if you have a class B that is a subclass of A, that is, if you write public class B extends A, then any object of type B is also of type A. In effect, B is a subtype of A. The second thing is, if a class C implements an interface I, then an object of type C is also of object of type I. So C is a subtype of I. Sometimes you never think about certain types of subclassing. For example, you don't want to have stack a subtype of queue. You don't want to say stack extends queue, or a button extends integer, list extends string, member extends catalog. They make absolutely no sense. They're egregious violations. But sometimes you are tempted to extend stuff, and some of them are right, some of them may not be right. So let's look at those kinds of things, like a square extends rectangle. Is that a good idea? Or rectangle extends square. Periodical, we have seen in connection with the library system. Can it be extending book, or vice versa? Or can you have a set that is an extension of list, or vice versa? These are situations where you might want to look a little further and see whether we are doing the right thing. So we have a general idea about those kinds of situations. Suppose B is a subtype of A, specifically with respect to subclassing. Suppose B is a class that extends A. We could say in a very general way that instances of B, that is, if you create an object of type B, it should behave like an object of type A as far as A's methods are concerned. That is, a user of A should not be seeing anything fundamentally different about B. What do we mean by this? Let's look at this class. This is a counter, public class counter. All it does is an object of type counter maintains a field called count, and it maintains the actual value of the counter. So you can up the counter by using this method up, and it increments the value of count by 1. You can get the current count value by issuing this method called get value. It returns the current value of count, and you can reset the counter by calling this method. It sets count to 0. So this is useful for counting the number of operations, whatever that operation might be. For example, we have a client of that counter. It does something in this method, do something. It gets a counter as parameter. And what it does is, as long as the value is less than 10, it does some work. If you want, you can put in a method called to reset the counter before the while loop. but I'm assuming that counter is set to 0 initially. Let's make that simplifying assumption. So in this loop, we do some work. All I am doing at this point is just printing a message, but it can be much more complicated. And then we count up, and then we check, have we done this 10 times? If not, we continue the work and then again increment and so on. All right, so we have a class counter and a client that uses this. Now, suppose we have a second class, counter2, that extends counter. So if you look at this counter class, it has 3 methods. I'm keeping these 2 methods as before, get value and reset, but up I am changing. In up, I increment count by 2 as opposed to 1 for whatever reason. So this counts up by 2. Now the client code won't work as before. If you get a counter object that is actually a counter2 object, that is the actual type is counter2, although the declared type is counter, when you call the method up on the counter object, it actually uses dynamic binding to go to this method and adds 2 to the count value. So this will not execute like before, which did it 10 times, this would do half that. So the client behavior is affected because we are getting a parameter that doesn't quite fit the expectations. So this subclassing, we can say, is inappropriate because the client behavior with the subclass object doesn't match the expected behavior. What about a different type of counter, public class enhanced counter extends counter? And what it does is it adds an extra method down, which decrements count by 1, provided count is non-zero. It is more than 0 rather. If you use this object or an object of type enhanced counter as parameter to the client, you can see that it continues to work as before. In fact, all clients of counter would work properly with enhanced counter because the methods of counter are preserved. And using a counter reference, we can never use methods of enhanced counter. So everything works out quite well. So this idea that subclass objects should behave like the superclass objects is captured in this famous principle called the Liskov substitution principle, abbreviated LSP. What it says is, if there is a property for objects of a certain type T, then that property should be true for all objects of the subclass of subtype, where S is a subtype of T. So this is primarily looking at the issue of whether a subclassing of an existing class is appropriate or not. So any property that is true of the superclass should be true of the subclass too. Let's look at another example. Suppose we have a class called set. You know, a set is an object that can store elements, but there is no order and there are no duplicates. So we have a method called add, into which we add an object. So into a set, we add this object using this method add. And before this method is called, the client should ensure that the object is not null. And the client is guaranteed that if there is room in the set, this object will be added to the collection. Now let's look at a second method of set is remove. We are not showing the code here. The method should be called only if the set is not empty and some element of the set will be removed and returned. Then there is a size method that tells you how many elements are in the set. The post condition is that it returns the number of elements of the collection. There is no precondition. It can always be called. Now let's look at a subclass of set. List extends set. And what we are trying to see is whether this is an appropriate way of subclassing. So the list is now going to override the methods of set. Here is the override for add. And what we are saying about this add is the precondition is object is not null, and post condition is that this will add the object to the end of the list. So the list has a certain order. There is a sequence of elements as opposed to a set of elements. So the new object will be added at the end of the list. So that is important. Remove removes the first element of the collection, unlike the set which removes any element. The precondition is still the same. The size method works exactly as before. There is no difference. It can be called at any time. It returns the number of elements of the collection. Now, you can see that the post conditions of list are either exactly the same or they are special cases of the set methods. For example, here, the size method of list has exactly the same post condition as the size method of set. Here, the post condition for remove is a special case of the post condition for the corresponding method of set. So is the case for add. The preconditions are all exactly the same. So these methods are not going to surprise a user of set. If you pass that user, that client code, a list object, the behavior of the code will not be any different. It will just behave just like a set. So this is an appropriate subclassing. And how can we tell? We can tell it from the preconditions and post conditions of the methods. The list methods are doing something more specific, and some sets could also be doing exactly the same thing. So you can never say that there is a violation of the methods contracts. So this is these slides are basically showing what we just said. Okay, now when you look at a superclass method, public void mdd1, then the subclass can have a method that looks like this, except for the parameter. The parameter C is a super type of D. So C is a super type of D. So D extends C, and the method M is placed in some superclass, let's say P, and this method M is in some subclass of P called Q. So this is in P. This method M at the bottom is in Q. Q is a subclass of P, and the parameter, as long as it is more general, or at least as permissive as the parameter of the superclass method, there is no real issue here, because the method is as generous in its receipt of arguments. If this takes in a certain object, the superclass method M takes in a certain object, that method will be accepted by the subclass method too. So a user of the subtype will notice no difference in terms of the parameters it can actually pass. It would only pass objects of type D or special cases of D, whereas this would be, all those objects would be acceptable to the overriding method as well. The other thing is, if the superclass has a return type of D for a method M, the overriding method can be D or a subtype of D, so that the return values don't surprise the client. You're only returning whatever the superclass is returning, not something that is impossible with the superclass implementation of M. Similarly, we also have restrictions with respect to the exceptions that can be thrown. If a superclass throws a certain exception, the subclass can throw only those exceptions or subclasses of that exception, not anything that is more general than the superclass method's exception. And what about Java? Java is a little more restrictive than what we have discussed. What we have discussed is what LSP allows. In Java, if you have M in the subclass that overrides the method M in the superclass, the parameters have to be exactly the same. If you have D here, you cannot put anything other than a D as a parameter here. But the return types would be exactly like LSP. E is a subtype or a subclass of D, then that is acceptable. Here is the superclass method M. It returns an object of type D. The overriding method can be D or a subtype of D. Why does Java not allow something that is a super type? There is no documentation related to this. You can think about it. I have my ideas, but I'm not going to cover that in this video.